Okay, good morning. Welcome to
MathyMath181.
MathyMath181. So this is a problem you picked out of your geometry book today. And it says the sides of a triangle have length 15, 20, and 25. Right?
Yeah.
And it asks you to find the shortest altitude in this triangle. So what is an altitude even?
It's perpendicular. Like, this would be an altitude.
Okay.
Well, this kind of triangle is a right triangle. Because if you divide the sides by 4, if you divide the sides by 5, you get 3, 4, 5.
Okay.
And we know this are 3, 4, 5 right triangle. So, because this is a right triangle, we already have 2 of the altitudes. We have 20 and 15.
Interesting. Okay.
To find the other one, well, the area of this triangle is 150, which is 25 times 6, so this altitude has to be 12.
All right. How did you figure that out? Can you say a little bit more about it?
So the area of the triangle is 150, base times height over 2.
Okay.
And then 150 is 25 times 6.
All right.
But since it's based on height over 2,
Okay.
you need to double the 6, so it's 12.
Nice. All right.
So it means 12 is the shortest altitude.
Okay, very good. Do you think, how do you think you're going to, in a general triangle, how do you think you're going to have to find the shortest altitude? What do you think you're going to have to do?
Well, you'd have to find all of the altitudes. And probably you have to compare all the altitudes.
Okay, interesting. How would you find the altitudes to begin with?
Well, if I only knew the sides, I could use Huron's formula to find the area of the triangle.
Okay.
And then find the altitudes from each side.
By what you did here.
Yeah.
Side times altitude divided by 2. All right, so my question to you then is, do you need to compute all 3 altitudes, or is there a way to know which one's going to be the shortest altitude ahead of time?
Well, I think it's the largest, the altitude going to the side opposite the largest angle is going to be the shortest.
Okay. How come?
Well, because the largest angle, it's sort of, the larger the angle gets, the closer the 2 sides come together.
All right. But unfortunately, we don't know how to find angles in a triangle yet. Soon we'll learn that.
Yeah.
That's a subject called trigonometry. Is there a way without finding the angles? Or do you have to compute all 3 and compare them? Is there a way without finding the angles to know which one is going to be the shortest?
Well, the one going to the largest side, maybe.
Okay. Why would that be true?
That also relates to my angle thing, too.
Yeah? And how else can we see that? That you only need to find the one to the longest side. What's another way without thinking about the angles?
Well, So, like in here, we only needed to find this one. We just already knew the other 2.
Yeah, well what if you didn't know the other 2? Like, let's say you knew the area of this was 150, but you didn't know it was a right triangle.
And we knew this was 25.
Yeah, you knew the sides were 15, 20, and 25, and someone had told you the area was 150, but you didn't know it was a right triangle. So how would you know that the shortest altitude went to the side that was 25?
Well, because that's the biggest, it's the biggest number, so you have to multiply it by the least amount to get it to 150.
Okay. So 15 times the altitude to the side of 15 has to be 300, right? 20 times the altitude going to the side length 20 has to be 300, and 25 times the altitude going to that side has to be 300.
Yeah.
So that's why. So you do not need to compare all 3, because you know it's going to be the altitude going to the longest side is going to be the shortest altitude. All right. Good work, hon.